Hi guys. Okay, so what we are doing now is we are in the same yellow note packet that we've been in since the beginning. The previous page was the quiz short answer problems, and prior to that was your quiz review. So right now what we are going to kind of transition into talking about is solving systems of linear equations. Okay, so essentially in a nutshell, a system of linear equations is where you graph two lines and you're finding their point of intersection. Okay, that's one method to solve this. That's the method that we're going to go through today. This was also taught during Algebra 1, so it's kind of a review also, so that's why it's in our review section. Okay, so definition, a linear system is a set of two linear equations. So sometimes these lines will cross and intersect, and they'll intersect at one point. What if they're parallel lines? So I could have two lines that are parallel. Are they ever going to touch if they're parallel? They will never touch, so they have no solution. But then, what if I graph a line and the other line happens to be on top of it? Okay? So it essentially becomes the same line, right? How many solutions do they have? Well, how many points does this line share that this line also shares? Hundreds, millions, thousands, 10 millions, or infinite points? All the points. So it would be infinite answers or infinite solutions. So here's an equation in slope-intercept form, and here's another equation in slope-intercept form. Okay? They want to know, does the point 0, 4 make either equation true? So first, I'm going to plug this point into this equation. So this is x, this is y. So 0 for x, so I get, and 4 for y. So I get 4 equals negative 2 times 0. So 4 equals negative 2 times 0. Anything times 0 is 0. So that is false. So what that means is that if I were to graph this line, this point right here would not lie on that line. It would be off of that line. Okay? Let's plug in to this equation now. So y is 4 equals x is 0 plus 3. So I get 4 equals 3, and that is false. It does not lie on that line, so it does not make either statement true. Now we're going to try with the point 2, 5. So I'm going to go with my first line. So 5 equals negative 2 times 2. That's 5 equals negative 4. So that is false again. If I plug this same point into this line, then I get 5 equals 2 plus 3, which is 5 equals 5. That is true. So what that means is that the point 2, 5 is actually on this line. So if I were to graph this line and I plotted the point 2, 5, it would be directly on that line. All right, let's try the last one. Negative 1, 2. Same thing. Plug it into this first equation. So I get 2 here equals negative 2 times negative 1. So two negatives make a positive when I multiply, so that equals 2. That is true. So that means the point negative 1, 2 lies on this line. And then I'm going to plug it into the second one. So I get 2 equals negative 1 plus 3. So 2 equals negative 1 plus 3 is also 2. So that is true. So what this means is it's true for both. So this would be a solution to my system of linear equations, which means that they actually cross, these two lines cross or intersect at the point negative 1, 2. And that's what we're trying to find in this section. So that's the first way you can solve those in the graphing. Just plug the numbers in if they give you a point, okay? If a point works in both equations of the linear system, the point is a solution. That's what we just talked about, to the linear system. When you solve a linear system, you're finding the one point that makes both equations true. What point is the solution to the system above? Well, we said it's not number 1, it's not number 2, but it is number 3 because it works in both. All right, so now we're actually going to graph those two things so we can actually see that. So this one, I have a y-intercept of 0, so I have my b is not there, so it's 0, so I have a point at 0. My slope tells me to go down 2, but over 1, down 2, over 1. And then this really shows why it's important to use a straight edge and why it's important to graph your line throughout the entire graph. Always, always, always. There we go. Oh, and I did these in the wrong colors, but that's okay. Okay, this one, my y-intercept is at 3. 1, 2, 3. My slope tells me go down 1, over 1. I'm sorry. My slope tells me go up 1, over 1, or down 1, backwards 1. Down, back, down, back. Okay. If you notice, they cross right there. That point that they cross is back 1, negative 1, up 2, which is the same answer that we found up here. Okay, so that's what it looks like when you're graphing. At what point do the two lines intersect? They intersect at negative 1, 2, which we already decided earlier was the solution. And that's the same thing as what we got in number 4. An ordered pair that makes a solution or a linear equation true is called a solution. The point that the two lines intersect is the solution to the systems. Oops, sorry. To solve a system of linear equations, the order pair must work for both equations. Okay? So let's go to the next page. All right. So we're going to practice this. So essentially, you're doing what you've already learned how to do. You are graphing these lines, right? So let's do the first one. In the first one, I have a y-intercept of 0, so I'm going to put a point there at 0. My slope is up 2 over 1. Rise over run. Grab my straight edge. Make that go through the entire graph. I'm going to use 2 different colors so it's easier to tell what color goes with each graph. Okay. This one has a y-intercept of 3, and it tells me I have a negative 1 slope. So that means go down 1 over 1, down 1 over 1, and keep going. Remember, we want at least 3 points on the graph. More is better, so we can get the straightest line possible when drawing. We see that they intersect at this point of 1, 2. So I go over 1 and up 2. When it says verify, it's asking you to check this. So plug it in, okay? So if I plug into my first one, my y value is 2 equals 2 times my x value of 1, which means 2 equals 2, and that is correct. And then I'm going to plug it into the second equation right here. Y value on this one is 2 again, equals negative x, which is 1, plus 3. So that's 2 equals 2. So it checks there also. So we verified that one. All right. Next one. This one's not in slope-intercept form, so we need to get into slope-intercept form first. So I'm just going to subtract 2x from both sides. So I get y equals negative 2x minus 4. So on that one, my b value, my y-intercept is negative 4, so 1, 2, 3, 4, down. My slope tells me go down 2 to the right 1, or up 2, backwards 1. And that should look correct because this is a negative slope, so my line should be going down because it is negative. All right, so did that in that color. Here it's already in the correct form, so my slope, or my y-intercept is negative 2, and my slope is up 1 over 1, up 1 over 1, down 1, backwards 1, down 1, backwards 1. Okay. Now, what I have here is they are crossing, but they are crossing in the middle, which is not a good sign. So I'm going to check myself. I'm going to do this real quick. Oh, do you guys see my mistake? See, I make mistakes too. If this is a negative 2x, I have to add 2x to both sides, so that should be a positive 2. So I'm going to go back to this equation. I'm going to regraph it. So, I still have a y-intercept of down here at negative 4, but now I'm going to go up 2 over 1, up 2 and over 1, up 2 and over 1, because it's a positive slope. Goodness gracious, see? You guys are not able to yell at me because we're not in class. Okay. Let me graph that. Okay, here we go. So here's where they intersect. But guys, that's a good thing. Like when we're graphing these, I'm not going to give you an answer where it's going to be in the middle. It's going to be directly on a point because we can't tell in the middle where it really hits at. So you need to check yourself when that happens. So I'm getting the point of 2, 0. And so now I'm going to verify this. So I'm going to plug it in. I can plug it into this top equation or the one that I created. I'm just going to do it into the one I created. So 0 equals 2 times 2 minus 4. Well, 2 times 2 is 4. So I get 4 minus 4. So I get 0 equals 0. So it does check there. And then I'm going to plug in that point to this equation. So I get 0 equals 2 minus 2. 2 minus 2 is 0. So 0 does equal 0. So that checks there. All right. What I want for you to do now is I want for you to pause me, and I want for you to do number 1, number 2, and number 3 on your own. When you're finished, go ahead and unpause me so you can check yourself. But make sure to try to do these on your own before you actually watch. I'm going to quickly go through these. Okay, so the first one, I have a y-intercept up here at 5. My slope tells me down 1 over 1, down 1 over 1, and so on. So there's that line. And then the next line, I have a y-intercept of 1 and a slope of 1 over 1. Good, they're crossing through whole numbers, so most likely we did that correctly, or I did that correctly. Hopefully you did that correctly. So my solution is right here at over 2 up 3, so I would put down my solution of 2, 3. All right, next one, I need to move stuff. So minus 2x from both sides. So we get negative y equals negative 2x plus 2. I do not want a negative y, so I'm going to divide by negative 1 everywhere. So I get y equals 2x minus 2. So y-intercept is down here at negative 2. Slope is 2, so that means up 2 over 1, up 2 over 1. Do that a couple times. Straight edge. And there we go. The next line is x equals 3. So what I'm going to do is I'm going to go over, right here is where x equals 3. And I'm going to ask myself, well, where else is x equal to 3? Well, x is equal to 3 here, and here, here, and here, and here. All those points right there. So that is a vertical line. Remember that slope is undefined. And it's at this point is your solution. That is over 3 up 4. All right, one more. Okay, so I need to subtract 2x from both sides to get this into slope-intercept form. So I get y equals negative 2x plus 2. Y-intercept is at 2 then. My slope tells me to go down 2 over 1 because it's down, because it's a negative 2 slope. All right, and then this guy, subtract x from both sides. So I get negative y equals negative x plus 4. I'm going to divide by negative 1 everywhere. So I get y equals x minus 4. So y-intercept is at negative 4. Slope is up 1 over 1, up 1 over 1. I'm going to keep doing that. And there's my point. That point is at over 2 and down 2. All right, so hopefully that made sense. If you have questions, make sure to jump up on a pop-up question, Google Meet, and then do your homework that goes along with this. And I will see you guys later. Bye.